welcome back to Just Blazor Programming. Today we're going to be doing cascading parameters for real this time, and not just a bunch of drawings trying to make a very poor joke funny. So in this case, we will be learning how to apply cascading parameters and all that goes with it, at least to the point where you can actually start using it in your code, how it works, what to do for certain cases, and essentially just we're going to code that in today. So, before I get into that, I would like to just say thank you very much for subscribing to me. And if you ever see my videos in the recommended, just click on them and don't watch them if you don't want to. But leave them playing for about a minute, and that'll help me a lot. Just kidding. Just help me out there. And here we go. Let's begin our project. So, please get your Visual Studios 2022 in my case. And we're going to create a new project. It really doesn't matter which one you created, whether it's WebAssembly or a server app. I'm just going to go with server app because that's like the easiest one to start. Blazor app, cascading parameters. Here we go. Blah, blah, blah. We don't care. This will work the same in either or. There's no real difference between the two. So just get it started. So cascading parameters. If you haven't seen my last video, basically what we're going to do is pass in values between components that are nested within each other. That's the gist of it. So how do you do that? There are different ways of doing that, but they all boil down to about the same basic functionality or the same basic way of doing it. And the whole reason why I made that video in the first place was to basically visualize it, because it gets more annoying to visualize it in code than if you don't do that. So with that being said, we are going to be building some pages. So when I say nested components, yeah, we're going to be building a few more components, and we're going to nest them in each other and pass values through them. In case you don't know, there was a video that I created that is about events and event handling. In that video, that is one way that components actually interact with each other, and this is another way. And then there's like one more way, but I don't want to talk about that right now. Ooh, I don't want to talk about that one right now. But in this case, we're just going to be building 3 components. Ancestor component, parent component, and child component. So do nothing to them for now. Just add them in here, and we'll be good. Parent component and child component. Perfect. Beautiful. Now we have our 3 components. Let's just go to the not that one. I want the one that says hello world. Yeah, that one. Get rid of this. We're gonna be using this page because it's gonna be grand. Oops. Yeah, I've been looking at my analytics. So what we're gonna do is the first thing we're gonna do is actually create the first cascading parameter. In order to do that, we need to create a property within our component here, and then give it an attribute, the cascade parameter attribute. So we're gonna test it out with just a very simple integer. Public int, and we'll just call it test. Get set. And I'm gonna set this to 200. And in order to pass these within every parameter, we have to add this to it, cascading parameter. Now there are 2 ways to pass in values between through a cascading parameter. The first way is by value, and the other way is by name. So we'll get to the name one in a sec, but for now, in order for you to actually have these work with the components, whatever components you're going to be nesting and the ones that you want them to actually receive the value, it has to all have this invoked within them. So the parent component also has to have its own, and the child component the same way. So here we go. And in our ancestor, actually not the ancestor, in our index, we will just have the ancestor component be there for the moment. And within our ancestor, we're actually going to be doing some of the work here to actually pass it in through our parents. So we're going to have this and then this. Actually, sorry about that. Actually, we have to do one more thing. And the parents, we want to get rid of these values here. The parent and in the child, we don't actually need to set them up. They're just going to be properties to house whatever the ancestor is going to give them. So we don't actually need to put like equals whatever, because they're going to be overridden anyway. So we have that, we have that. Okay, good. So how do we set up our cascading values? We have our ancestor component set up in the index, so that's good. So within the ancestor component itself, this is where we set up our cascading value. So that's how you do it. You need the cascading value component here. You put in the value at test. Go. That's how we're gonna pass that in there. And now we're gonna get the parent component from here. And just add it in like that. Now we have to know what's going on, so I'm just gonna set up some quick HTML. We're just gonna have ancestor test integer down here. And we're gonna do the same thing for the parent component. In the parent component, all you saw me do was just copy paste it here. And we're gonna change the name from here to parent. And now we're gonna bring in the child. And I don't believe you need to add the cascading parameter value here, but we'll see. And you do the same thing that we did here to the child component. And we just say child. So we're gonna look at our first cascading value. Yeah. I got nothing else here. We'll just see if it works. And it does. So we don't actually need to add the cascading value component to the other ones that come afterwards, as long as the cascading value component is in wherever we're passing it through. So once we pass it to the parent passes it to the child, because in theory, in the background, they're all encompassed by that big cascading value thing passing 200 to each of them. So that is what we call passing it by value. Now we can also pass in multiple cascading values if we wanted to, and we're going to pass in this next one by name instead. So what does that mean? I want to pass another int, but we're going to just say test int name. There's going to be a reason for this in the end. We're going to give this number 333. And all you have to do to set up the name is this. No. Name equals test int name. But what's going to happen here is that instead of looking for a value to pass it in through, it's going to look for the actual name. So once it's called test int value, that's exactly what it's going to assign it to once it goes down the components. Do the same thing here. Remove that. Here, do the same thing. Move that as well. And then we are going to go and do this. Child test int name. And then we will grab the int name here. I'm not going to add to the parent because I want to show you something else that you don't actually need to do anything with it if you don't want to. You can literally just have it as a property. As long as you have the cascading parameter there, you could just pass it in through and not use it in the component that you're just passing it through to get to the end. So in this case, we're going to leave the parent out of it and just have it pass the value between ancestor and the child at the end of it all. Oh, I forgot to add it here to the ancestor, but you'll see. Child testing name. Oh, that's right. Because I didn't pass it in by value. I mean, I didn't pass it in through the component. So in order to pass another one, you do need another one of these components. And that's how it is. Here. Put the parent within that component as well, the cascading value, and now change it to the test int name. But we also need to set up the name as well here. And this will know that you're going to pass it in by specifying the name. So I don't think you need to do it on both sides, but I'm going to check it just in case. So you'll see in real time me asking questions and figuring out the nuances of these cascading parameters, because I thought they were fairly simple, and it did pass it in by name. So what I'm going to do is get rid of this thing just to do a quick test. So if I'm moving very fast for you, I'm sorry, just because I'm very, very interested. I didn't do this in my testing before. And it does. Seems to work pretty well. Pass it into the int name. Now, the reason why I say it works well and there was nothing happening is because there's something interesting that happens when there are two values that are the same type, but there's no way to differentiate them. So what happens if you have this case? Now we have two integers essentially being passed through. How does the parent component know which integers to pass in those values to if there's nothing really separating them? So what I will show you here, all right, is that something will change. I'm going to get rid of this too. Forgot to get rid of this. Here, here. Now we are purely passing it in as a value on all accounts, and there's nothing really to separate it. As you can see, exactly what I thought would happen. What happens is the component that is nearest to the cascading value that is nearest to the component will be the one to assign the actual value. That's why 200 doesn't get assigned to the parent or the child component, because in our case, the value that is closest to it is going to be this one, test int name. And that's going to happen even if you didn't or did not have tested name. It's just going to pass in because it doesn't know what else to do with these values. It doesn't know that it can assign two different values or not. It just knows that it's looking for a value of integer, and it's going to assign it that value of integer, whatever it is. So it's not even going to bother taking test ints because it's above, it's further up the chain. So it only will take the ones that are closest to it, which is why you want to do the naming parameter stuff that we did before. And I'm actually going to put that back. So although you don't have to do it on both sides, I think it might be easier to see it this way. So we're just going to do that. Then down here, because we're not actually invoking any cascading parameter stuff here, it's again just good for us to see. And then I'm going to do the same to the child. I like consistency. I like doing things like this. It's just more helpful. So now we've seen examples of passing in by value and passing in by name. And not only that, but we could pass in multiple values. And what happens when you have multiple of the same value competing for one type, essentially. So whatever the closest one is will be the one that takes over the types that it's expecting. And you can do more with this. You don't have to just rely on in primitives. You can also do things with more complex objects. So I'm going to create one right now. We're just going to add it right here to the data file. A very simple object, but an object nonetheless, because I'm also going to show you that every component is essentially its own island until you hook in things to allow you to pass in values. So in this case, we're just going to add a new item, a new C# class, and we're just going to call it a simple object. That's it. What's going to go in this simple object? We're going to put 3 values in there. One int, always like using this kind of schema for things. One integer, we'll just call it, the ID. Sure, why not? And then we're going to have a public string name. Sure. And then I want a bool as well. We'll just put allow. We're not really going to use it for anything except just to show that we're passing in a value. So thanks to C#, getting updated, or not getting updated, should I say? Ugh. Gonna have to do that just to be, you know, more null friendly or whatever that they decided to do. And there we go. So within each component, you're gonna have to add the actual namespace of that object that we just added, because you don't actually pass in these namespaces down the component line. Each component is its own island essentially. So we want to pass in the what's this called? Blazor dot data. So we're gonna pass in that object as a parameter as well, and it's gonna be basically the same process. But there's something I want you to know. That was in the toggle, but we're gonna have to add them to all of them anyway, so it doesn't matter. Here we could remove the value, because it's not gonna confuse it for an object. Your original objects are more unique than that, unless you have like maybe 2 objects or whatever of the same type. Then that could cause an issue. But normally you're okay if you're just using one object of a type within to pass the parameters through. That's what I'm going to do now. We're just going to pass in the object by value. I'm going to call it a child object. And in this case, we're going to do the same thing, except we're going to call this a parent object. So because I'm passing in by value, I'm demonstrating that it doesn't care about the name. Oh, also it doesn't need to add the right here. Simple object equals to null. That's what we need right here. Oh, this is the child component. Oops. Sorry. If you saw that mistake and were yelling at me, you know, I deserved it, and you should tell me about it in the comment sections of all the mistakes I'm making. Every single one of them. I'm not gonna be able to stop you anyway. And I don't bother deleting comments unless I'm like a robot or something. So we're gonna do that here in the child component. We're gonna add a simple object cascading parameter. Then we're gonna go to the parent. So it will be called the parent object. And then the ancestor will get one as well. Cascading parameter. Public object. Tester object. Get set. But we're gonna actually create an object with this one. We're actually gonna set a value up. Because if not, it's not gonna be very easy to tell what just happened. So I just added that up here. And now we're gonna set a new object, a new simple object. Or what do they call name? And call it Stan. For those of us with dyslexia, it might look like Satan or Santa. So, you know, don't worry. I feel you. Allow equals true. And then, what was the last one? It was some number, right? It was just it was an ID. ID of 3 or 2. Yeah, perfect. So here we go. We have our ancestor object that's going to have Stan, allow true. And we're going to do the exact same thing we did last time. We're not going to bother setting it up for the parent, except for passing in the parent object. And for the child object, we do want to see what happened. So we're going to grab that data and display it within the child object. And basically, we're just going to display all the data here. So dot name. And make sure you put that there just in case. I'm gonna copy paste this a few times. And then we'll grab the ID and the what was the last one? Oh, the Boolean value, yeah. So I think that's good. Whatever. All is fine. Parent has its object. And now we got to pass in that value as well to the cascading value. Put the parent right in there. And we're going to pass in that object. Value equals at ancestor object. And that should be able to pass in all of that through. So this is just us passing in an object itself. And let's see what happens. And as expected, we pass in the ancestor object all the way down to the child component. It starts from, yeah, we pass it all the way down, and these are the values: stand, to, and true. And the child is getting the correct integers that we set up because it's getting by name, and this is getting it by value. So it knows the difference. And because the child object, the simple object that we set up is unique in that sense, it knows that it could pass it in through like this. But there's one more thing that I should go over before we call it a day, and that is this. Actually, let's not do it here. Let's do it with something a little bit easier. IsFixed equals to true. So if you go deeper into the cascading parameters, the reason why you want to add something like this, or what this is for, is because the way that cascading parameters work is that each one of them monitors a change from the last one. So when the ancestor actually passes in all these values, the cascading values are constantly monitoring for a change, which is why you can change a value in the ancestor, and it's going to be felt throughout the entire tree. So why that happens is because there's an automatic monitoring going on, and that costs processing power, or that costs processing, and that can performance, should I say, and that can cost you if you have multiple of these doing it a lot at the same time, that can make your application very, very slow and inefficient. So a way to mitigate that is by using the IsFixed value. Now this isn't a block, so if I write IsFixed here, what's going to happen is that this test int is just not going to be monitored as we go along. But if you do change it, it will be able to change the rest of the values. What's happening in the background is that the monitoring itself, the automatic monitoring, is being turned off, but that doesn't mean that you can't manipulate the values after the fact. You're basically saying that if I apply these fixed, I don't want the monitoring to happen, so things can happen, like it could go out of sync within each other, and I'm going to demonstrate that now. And also, essentially what you want to do is use IsFixed when you know that the value you're passing down is never going to be changed, or you don't, you never want to change it. So you turn off the monitoring so that, because you don't really need the monitoring anymore. But there's still going to be some updating of things, even though it's not actively monitoring it. So if that doesn't make any sense to you, don't worry, I got you. I'm going to put the IsFixed true here. But we need to make a function real quick in order for us to demonstrate what this is happening. So this is for our test int, right? So we're going to go to the counter component and steal from stuff there. We're going to take this button, go to the ancestor here, put this button right there. And then we're going to steal the actual the increment count function, and also put that right there. And instead of it being the current count, we're going to put it as test int. So just to show you what's going to happen here, we're going to get rid of the IsFixed for now. And we're going to update it with this increment count that we've added to the ancestor component. So here we go, 200, 200, 200. Each one of them has updated to 201. And every time that I updated this one, even this is only in the answer component, each and every other value gets updated as well. So just to show you that there is monitoring going on, that is what's happening in the background. That's why they update as they do. So if I put the IsFixed, equal to true, makes no difference. Makes no difference because even though the monitoring, I told it not to monitor it, I'm still changing the value and it's still gonna be doing stuff in the background in order to get the value to update. And the only way that I could see a change actually happens if I do something like this. This is in the parent component. I'm gonna move the child component in here. And the value we're using is this test int value here. And we're gonna set the IsFixed to true here as well. As you can see, what I was talking about, things getting out of sync, this has just happened here. Because I had the IsFixed here as well, the monitoring isn't as precise anymore. And because it's like on the next layer coming down, it's not gonna actively look for the change, but it'll still gain the changes. It's just like off by now. But that's basically the proof that I have that there is monitoring going on, but your component is gonna actively keep checking itself for changes and stuff. The only reason why the monitoring is there is so that it actively checks for changes up in the chain somewhere, and that it syncs with those changes. So that's what the IsFix is for. So it's basically just you trying to optimize how your application works. Basically by saying, I don't feel like changing this value, or I don't have an intention of changing the value. So we're going to turn off the monitoring because I have no need for it. And that causes performance issues. Or if there's too many of these things going on, it causes some performance issues in your application. And there's one way of mitigating that through these cascading values. So even though cascading values are really really convenient for a lot of things, especially if you have like an application that you need to pass in the same data over and over again. So instead of making all those database calls, you could just pass in the data through. Unfortunately, there is a price to pay for that, and that's the performance. So if you already know that there is going to be a data set that you're working with and you don't need to actively change it, then you're good if you use this, and then you save some performance hassles in the future for your application. And I do think that is everything we got for the cascading parameters. I went over how to implement them, value, strings, how multiple values work together, and the interaction between having multiple parameters that are of the same type, but you don't have differentiated them with a name or something. That's the whole point of the name, by the way, is to make sure that you differentiate them. And then how to save some performance by doing the IsFixed, adding the IsFixed parameter through the cascading value you want. So they're not really that difficult. There are a lot of things that you can use with them, and it can cause some performance problems. But if you just keep in mind, what exactly you want to pass and whether or not you're going to change that value, then you should be good. Cascading parameters aren't that hard. But if you want a more visual explanation, I did make a video for that, so you can check it out. And that's it, Just do me that favor, like, subscribe, comment, do all that stuff. And if you see my videos and recommended, click it. And if you don't want to watch it, don't watch it, but just help me out, please. I beg you. I'm begging.